This is the official channel of the International Association of Astronomical Artists. And today, we are going to do our first ever tour of an exoplanet. We're going to visit the darkest planet in the universe, at least the one that we know of. It has been dubbed TRES-2b, or simply 2b. This place is absolutely mind-bogglingly dark. You could put all the matter in the planet together and it would still be less reflective than coal. So how do we even find planets like this? Well, TRES-2b was discovered by the Transiting Exoplanet Survey satellite. Yep, that is really the name of the thing. It's not a very catchy name, but what a great accomplishment. NASA launched this space telescope back in April of 2006 to discover planets outside of our solar system. Since then, it has found over 1,500 confirmed exoplanets. It does this by staring at stars and looking for dips in their brightness that might indicate a planet passing in front of it. When a planet passes in front of a star, it blocks some of the light from reaching us, so the star dims slightly. And if we can detect that dimming, we can figure out things about the planet, like its size and how far away it is. But there's a bit more to it than just the dip in the brightness. By measuring how much the star dims, astronomers can work out the size of the planet. That's because bigger planets block more light and therefore cause a deeper dip in brightness. By measuring how long it takes for the dip to happen again, they can calculate how long the planet's orbit is. And so they can calculate how far away the planet is from its star. TRES-2b orbits a star called TRES-2. Now, no, it's not actually called TRES-2. That's the name of the planetary system. But astronomers have given the star a designation of its own. They call it GSCO 354902811. Now, that may be a mouthful, but I think we should just call it TESS. After all, that is where the whole story started. So we have a star out there with the lovely name of TESS. It is a bit of a boring star, though. It is very similar to our sun. It is basically the same temperature and shines with a similar brightness. But there's one key difference. It is smaller than our sun. Our solar system formed from a giant cloud of gas and dust about 4.6 billion years ago. As the cloud collapsed, most of the material went into the center, forming the sun. But there was still plenty of stuff left over, enough to form at least 6 planets. This is why astronomers call our solar system a system of 8, including the sun. But not every solar system forms the same way. Some stars only manage to form a few planets, while others form none at all. And it seems that TESS didn't form any planets at all. At least we can't find any planets around it. Or maybe it did form planets, but they are so small that we can't detect them. In fact, that is a theory for why some stars don't seem to have any planets at all. They may have a bunch of small rocky planets that are too small for us to detect. It is possible that these small rocky planets are actually the most common kind of planet in the universe, but we are just too dumb to find them. But back to TRES-2b, the only confirmed planet around the star. The planet is about twice the size of Jupiter, but it is at least 700 light-years away from its star. To put that into perspective, the distance between the Sun and Neptune is about 4.5 billion kilometers. That is the length of about 300 million American football fields lined up in a row. So the distance between TRES-2 and its planet is about 12 times that distance, which is pretty far. Because of this vast distance, the planet receives about 1/10,000th the amount of sunlight that we get here on Earth. And remember, this is a gas giant, not a rocky planet like Earth, so it doesn't reflect much light anyway. In fact, it reflects almost no light at all. Astronomers estimate that it is less reflective than coal, which is already incredibly dark. Coal is usually black, but it reflects about 5% of visible light. TRES-2b is estimated to reflect less than 1%. So what is this place like? And what is it actually made of? Well, let's start with the obvious. It's made of gas. We know that because if it were made of rock, it wouldn't be able to orbit the star at all. Rocky planets are big and heavy, but they're also small and compact. A rocky planet the size of Jupiter would be so heavy that it would probably collapse in on itself due to its own gravity. Gas giants, on the other hand, are much less dense. And this means that they can orbit stars without crashing into them. But being a gas giant isn't enough to explain why this planet is so dark. After all, Jupiter is a gas giant, and it is not particularly dark. Jupiter is a beautiful planet with swirls of gold, brown, red, and white clouds. Jupiter is often called a gas giant, but it is really more of a liquid metal planet, at S, because the pressure deep inside the planet is so great that it squeezes the hydrogen gas into a liquid. And it doesn't stop there. The pressure is so great that it even squeezes the liquid hydrogen into a form of metallic hydrogen. Metallic hydrogen is a fantastic conductor of electricity, and it creates huge magnetic fields. In fact, Jupiter's magnetic field is the largest in the solar system, being about 14 times stronger than Earth's. It is these magnetic fields that create the beautiful auroras that we see on Jupiter. So if Jupiter is made of hydrogen, then surely TRES to B is made of something else, right? Yes and no. You see, TRES to B is also made mostly of hydrogen. But unlike Jupiter, the hydrogen is not in a liquid state. It is in a supercritical state. Imagine taking liquid water and heating it to over 300 degrees Celsius. If you keep heating it, the molecules start moving so fast that they break their bonds with each other. At this point, it's not quite a gas, but it's not a liquid either. It becomes a supercritical fluid. This supercritical hydrogen is extremely corrosive, and it eats away at everything it touches, including solid matter and even light. That is why TRES to B is so dark. Hydrogen eats away at the photons, trapping them inside the planet and preventing them from getting out. Now, hopefully you'll excuse me, but I'm going to use this opportunity to say two very important things. No one. If you love astronomy and art, then be sure to check out the website. There you can buy prints of my artwork and support my work as an artist. The link is down below. No, two. If you are interested in seeing more videos like this, then be sure to subscribe. It's free, and you can unsubscribe at any time. Also, be sure to hit the bell icon so that you get notified when I upload a new video. Okay. Now where were we? Ah, yes, the planet TRES to B. How could I ever forget? TRES to B is about 14 times heavier than Jupiter. This makes it one of the most massive exoplanets ever discovered. This makes it one of the largest exoplanets ever discovered. So we have this huge gas giant orbiting this tiny star. Surely it must be hot, right? The planet receives so little sunlight that it is about 700 degrees Celsius. It is cold enough to freeze methane into a solid. So we have this huge ice cube orbiting this tiny star. And it is so far away from the star that it takes 11 days to orbit it. Can you imagine? On Earth, it takes the moon about 27 days to orbit our planet. So the moon goes around the Earth 4 times in the same amount of time that this planet goes around its star. And if that wasn't weird enough, the star itself goes around another star. That's right. TES is part of a binary star system. It has a partner star that is about half the size of the Sun. This star is small enough that astronomers have given it a name. They call it von Mane's star, after the Dutch astronomer who discovered it, of course. But it is also small enough that it is visible to the naked eye. If you lived on Jupiter, you could see this star in the night sky. It would look about as bright as Venus does from Earth. So as well as having a planet that is almost the size of the Sun orbiting it, TES also has a partner star. That's a pretty unusual combination, but not impossible. In fact, astronomers have seen many stars with planets that are close to the size of our Sun. They have seen many binary star systems. But this is the first time we have seen both of these things together, and I think that is pretty cool. I hope you enjoyed our tour of TRES to B. This was just a quick look at one of the many fascinating exoplanets out there. There are thousands of planets waiting to be explored, and I hope that one day soon we will be able to visit them all. But for now, we have to be content with just looking at them from afar. I am the host of this channel. If you want to learn more about astronomy and astrophysics, check out my courses on a learning platform. All links are down below. And finally, if you want to support my work, please consider becoming a patron. Your support helps me to continue making great content. Thank you for watching, and I'll see you next time.